Hello, welcome to this live technical discussion series. And we are very much excited to start our 50th session on related to this live discussion. And thank you all for your support in this unique initiative. And based on your response, of course, now we are planning so many more sessions, so many different kind of initiatives we are thinking of, which are of, let's say, similar nature. Okay, so once again, thank you all. So we'll welcome all your feedback, suggestions, or your experiences, whatever you have with respect to this unique initiative. So we would like to receive the same in the chat box below, and we'll be extremely glad to receive the same from you. So very good morning to all of you. I can see many members have already joined. Okay. So this stream is right now live on the three platforms on Facebook, LinkedIn, and YouTube. And if you want, you can switch the stream on this YouTube link. Okay, because this stream on YouTube will be relatively more smoother as compared to the different platform. Okay, and you may please like and share this video with the interested engineers in your circle so that we can start receiving diversified questions from the audience, as well as the larger number of engineers may be benefited with this unique talk which we are going to have. Okay, just after a few minutes. Okay, and if you want to receive the regular updates from our site, then you can register on this link. I'll just put up that link here. Yeah. Okay, so once again, very good morning to all of you. Good morning, Narayan Rao. Good morning, Aman. Good morning, Nikunj. Good morning, Dr. Ajay. Good morning, GB Suresh Kumar. Good morning, Ranjan. Good morning, Pratik. Good morning, Prem. Good morning, Rakesh. Good morning, Krishna Sahakari. Yes, good morning, Vishwanath. Good morning, Prasad. Good morning, Nikunj. He's telling thank you, team, and Bhavin Shah. Thanks a lot. I'm practicing as a structural engineer in Nasik since past 4 years, and these lectures will help me a lot in practicing. So thanks a lot for participating. And of course, you can always keep interacting with us, and then please suggest us that which are the topics on which you would like to have this kind of a discussion. Yes, good morning, Vipul. Good morning, Sushil. Good morning, Kamalbhai. Good morning, Rajiv. Good morning, Professor Maina Goshal. Yeah, so we are experimenting with the time in this our unique live discussion. And this is I think for the first time we are arranging it on the working day and in the morning time. Okay, yes. Good morning, Manish. Good morning, Anilji. Okay, good morning, Sahabuddin. Okay, so once again, very good morning to all of you. And we were thinking about IS 456 2000. So we were receiving few queries from the participants that let's arrange kind of a live discussion on this code. So then we were wondering like how many engineers really may be interested in this kind of a session. So with this, we decided that let us float this event in the social media, and then let's start collecting the questions, and then we may have kind of a questions Q&A kind of a session. And let me tell you that we have received more than 750 plus registrations, and there are many interesting points. So of course. We will be able to talk about certain points out of the many points whichever have been suggested, and then of course we will try to figure out the mechanism by which the remaining points may be addressed. Okay, so now let us invite Dr. Ashok Jain. He has just joined with us. Yes, good morning, sir.
Hello, good morning, good morning.
Yes,
How are
yes, sir.
you?
Yes, absolutely fine, sir. So I was just telling sir that there was a quite overwhelming response to this IS 456 2000. So we were wondering that how many engineers really may be interested. But we have seen, we have received the response from the engineers who have experienced more than 40, 50 years, and to the freshers. So it's a completely mixed crowd and from different parts of the country. And the response was actually reaching more than 750 plus people. And while just going live, I was looking into the registration form, still questions were coming, sir, related to 456. Yeah, yeah. So over to you, sir.
Okay, thank you. I
Yeah.
think this time you have changed the software. It is not Zoom anymore, right?
No, this is not Zoom. Yes. Yeah.
Okay, okay.
Yeah.
So how do I share
You
my
need
screen?
you need to click on plus. So first of all, you can open your PowerPoint presentation.
That I've already opened.
Open, sir. Then click on present, sir, on the bottom screen.
Share screen.
Yeah. In that you can click on window.
Window. Okay.
Yeah, and you can choose the applications. Yes, sir. Just need to make it full screen.
This is already put.
Okay. Okay.
Already full
So
screen from my side.
okay. Okay. Otherwise, sir, you can see you can share the complete screen. Yeah. Yeah. Just wait for 2 minutes. We were just sorting out. Meanwhile, you can all suggest, let's say, different topics on which we can have this kind of a discussion, or let's say your feedback, your experiences related to this live technical discussion. So we'd be glad to receive that input from your side. Yes. So very good morning, Suharman Khan. Good morning, Siva. Good morning, Kazi. Yes, sir. Yes, sir. Now you can switch on the PowerPoint, sir. You can click on the PowerPoint screen. Okay, ductile detailing is what? Yes, perfect, sir.
Nice. Okay.
Yes, yes, sir.
Okay. Okay.
Okay. So you can just click on the hide button on the just near to stop sharing. Yeah, so that pop-up will go, sir. Yeah,
Okay. Good. Good. Good.
yeah.
Well, a very happy good morning to all the participants from every corner of the country, and I'm really glad to be here this morning with you. Bhavin, there's an echo. Hello,
Yes, sir.
hello.
Yes, sir.
There's an echo.
I can also hear some certain sound. Oh,
Let
but
me
but
check.
you're audible, sir. No problem.
Okay, fine.
Yeah, yes. Yeah.
So let me first give you the background of this discussion on IS 456. Mr. Bhavin Shah was very keen to have a detailed discussion on IS 456. Frankly speaking, I wasn't sure how many participants would be interested in this code anymore. But Mr. Shah understands the pulse of the designers, students at all levels, beginners, middle, and senior level. He was confident that we should float such a course. It was a pleasant surprise to note that there were more than 700 queries from all over the country and from all levels. I believe it is first such webinar on 456 after a very long time. Just to give you an idea, the first edition came out 53, second edition in 1957, third edition 1964, fourth edition 1978, but really published in December 1979. For almost 1.5 years, it was simply not available. Then fifth edition came in year 2000. Okay, these are the revisions so far. Now, as far as 456 2000 is concerned, there were minor changes in this edition, mostly in section 2 on materials, workability, durability, and inspection aspects. Rest remained unchanged. Therefore, it is essentially a 1978 code till date. This was based on British Code CP 110 1971. CP means Code of Practice. Okay, and later on, BS 8110 superseded CP 110 in 1985. What it means is no revision for the past 44 years since 1978. And if you consider its date from CP 110, 1971, then it means our code is 51 years old till date. Unbelievable. Absolutely unbelievable. We are using a 51-year-old specification in 2022. And revision so far. All of our structural engineering codes were simply ditto copied from the British codes. Okay, comma, full stop, everything same. Okay. However, with the introduction of Eurocodes, things became quite difficult. Remember IS 800 2007, which is based on Eurocode 3. In fact, it is a copy of Eurocode 3. Teachers, designers, and students are still struggling with this code even into 2022. Europeans carried out extensive 10 years training program all over the Europe for teachers and designers before implementing the Eurocodes in various local languages. Okay. Can't guess what is going to happen in the next revision of 4, 5, 6. Queries from the participants. Mr. Bhavin forwarded me all the queries that he has received for this particular session. Okay, there are more than 700 queries and very interesting and very fundamental queries. Okay, I naturally can't include all the queries that were there, but some of the important questions were from where to start the code. Okay, code is such a big document, and there are so many codes. So from where to start? Okay, that was the first question. What should I look for in the code? How do I relate it to the field? Next revision, when and what? When is going to happen and what will it contain? Enhance shear strength near supports. Design of slender columns. So these three questions were very common in almost or most of the queries. Okay, and then the last question was how to become a good structural designer. Okay, so these were the some of the most common queries. I will try to answer as far as I can. As far as next revision of 456 is concerned, it is under revision for the past almost more than 5 years. It is likely to combine 456 and 1343, that is the pre-stress concrete. Likely to include a section on stress strain behavior of high strength concrete. Not expected to have any change in the current limit state design of beams, columns, slabs, etc. Okay. As far as the theoretical design is concerned, I don't expect much change or any change in these elements. BIS assigned the job of writing draft code to selected experts who are treating the draft as a best kept secret till date. They are simply not willing to share any document, any information at all. I don't know why. It's unbelievable that in such a technical forum, the drafters want to keep it a secret. Can't guess when it will see light of the day and in what form. What I would like to see in this revised 456 code. First of all, this should rationalize the partial load factors. Okay, as I mentioned, these are based on BI's British Code CP 110 1971. Okay, things have changed drastically as far as the partial load factors and load combinations are concerned. So we should move to the latest uh, practice being followed in the other leading countries. Another thing is this code should combine 456, 1343, and 13920. There is absolutely no reason why should the materials part of 13920 should be separate from it. India is the only country where the uh, specifications for earthquake detailing are not part of the basic material code. Okay, there should be only one material code for the whole country, whether it is buildings, whether it is bridges, that means Indian Road Congress, and Indian Railways, that is IRS railway codes. Okay, then they should rationalize shear and torsion clauses. Our both shear and torsion clauses are, very difficult to understand, and they're totally arbitrary. Then there should be genuine clause by clause commentary in the code. Okay, and it is possible only if the entire code is done systematically and logically. Okay, if you copy, edit, paste from different sources, then obviously the flow gets lost, the logic gets lost, and there is no way you can write a commentary which makes sense. Okay, let us also share a bitter truth about the state of research in India. To the best of my knowledge, there is not a single clause on any structural engineering code of India that was developed indigenously in the country. Okay. All codes are based either purely on British code or a combination of British, American, Australian, and other codes. Take for example 456, 800, 875 part 3, 1343, 3370, 1893 Part 1, Part 2, 13920, 16700. IRC 24, that is for steel bridges, is a copy of Eurocode 3 with minor changes. IRC 112 is a copy of Eurocode 2 with minor changes. Yes, it is true that some of the recent Indian codes 1893, 13920, 16700 are based on copy, paste, and edit technology with natural consequences. What I mean is, since the logic gets lost and some of the clauses are totally arbitrary, okay, therefore, several clauses of 800, 1893, 1920 are not implementable in popular softwares available in the country and but being used extensively by our design fraternity. Why no basic research in India? It's a very interesting question. Why no research? Although there is a lot of research, but it doesn't make sense. Research on materials is carried out in laboratory with only slight data processing on computer. That means more than 90% time is to be spent in laboratory. It needs a fully dedicated team of 3 to 4 faculty members for whole life and number of students, both PhD and MTech, at each major institute. Okay, in the absence of this manual infrastructure, you cannot do research and justification for the research on materials. Okay, it's a very slow and painful program, but highly satisfying both personally and professionally. Let me tell you, there is no shortage funds for research in India. You will be surprised to know that the government of India, through its various arms, is spending billions of rupees on so-called research, but the output is absolutely open to question. There is absolutely no accountability of research, how the where the money was spent, and how, what is the outcome. Okay, they just produce an n number of MTech theses, PhD theses, and hundreds of thousands of research papers published in garbage journals and conferences, and they call it research. That is the reason why there is not a single clause in our any structural code. Government of India is wondering again and again how come not a single IIT university is in top 100 in the world. Okay, and that is the reason behind it. There were a lot of questions about the stress strain curve in IS 456. They were asking why rectangular stress block is not there. Let me tell you, please read clause 38.1c. It permits rectangle, trapezoid, parabolic stress strain distribution for concrete. It means Whitney stress block rectangular is very much permitted in 4, 5, 6. The point is, why use an approximate curve when a better curve or an exact curve is easy to use, that is parabolic curve. See, our problem is very simple. If they give exact formulation, they say no, we want approximate. And if they give approximate, then we want exact. It's a very strange situation. Okay. A lot of our participants asked this particular question. Let me elaborate on this. This is the first figure shows the section with some reinforcement. Second, the strain diagram. Third, the actual stress diagram and the neutral axis. And below the neutral axis, concrete has cracked. Therefore, there is no stress taken by concrete. Only the entire tension is taken by steel. which is sigma y, and the force is tension T. Now you can replace this actual stress diagram with the rectangular stress diagram as shown in the last figure. Okay, this is called Whitney's stress block. Whitney introduced this in late 50s, 1950s. Okay, and what is the condition? The condition is that the area of this rectangular block must be equal to that of the actual stress diagram shown on the left. Okay. Second condition is the centroid of the rectangle must coincide with the centroid of the parabolic diagram shown on the left. Okay. Now with this condition, you can use rectangle stress block. So please tell me where is the simplification? Because your stress block, so-called rectangular stress block, is totally dependent on the parabolic. So you have to find out the area of the parabolic stress diagram as well as its center of gravity. Okay. Remember, in the rectangular stress block, the depth of the stress block A is doesn't go up to the neutral axis because of those two conditions, that the area must be equal and centroid must also be equal. Okay. Therefore, please forget about this myth that rectangular stress block is easy and convenient to use. Absolutely not. Now this is the parabolic stress block parameter, and partly the stress strain curve is parabolic and then it becomes rectangle after a strain of 0.2%, and the maximum strain concrete can take is 0.35% in flexure. Okay. Now based on this, we can very easily derive the force of compression and force of tension. Lot of participants asked a very interesting and important question: how do I remember these formula? Okay. Okay, there are so many formulas, I just can't remember it. Frankly speaking, you are not expected to remember these formulas, okay, and there is no need to. Okay, I'll tell you why and how. The force of compression in the parabolic stress block is equal to this formula, which is equal to 0.255 sigma ck b into x. X is the depth of neutral axis. C2 is the force of compression in the rectangular stress block, which is 0.287. Total force of compression is 0.542 sigma ck bx. B is the width of the cross section and x is the depth of neutral axis. With a partial safety factor of 1.5 on concrete, the effective force compression becomes 0.36 sigma ck bx. This is the only number that you need to remember. Now, force of tension in steel is sigma y at, if the area is the total area of steel, divided by the partial safety factor, which is 1.15. That is equal to 0.87 sigma y at. Okay. For equilibrium, force of compression must be equal to force of tension, and that gives you the depth of neutral axis x. So if you just remember the two numbers 0.36 and 0.87, then you know how to calculate depth of neutral axis. And then lever arm is d, which is the effective depth, minus 0.42 x, and then x in neutral axis. Therefore, the moment of resistance with respect to concrete is Cz, and with respect to steel is Tz. That's all. That's all you have to remember. Okay. I think now it becomes quite simple and easy. Okay. There's no need to cram. You just have to understand the equations. stiffness modifiers in 456. A lot of people ask this question. Okay, as I said again, that this code has not been revised since 1978, or maybe we should say 1971, and in clause 22.3 it permits stiffness based on three criteria. Okay, gross, transformed, and cracked. Okay, so the code always permitted you to use the modified stiffness. Only thing is it didn't give those stiffness coefficients because it was not there in 1971. It left to your discretion and judgment. In non-seismic area, small buildings, maybe 3 story, 4 story, 5 story, this gross moment inertia gives reasonable results. Okay, high strength concrete. Okay, again, a lot of people ask about this question. Uh, what is the stress strain curve for high strength concrete? Let me tell you, for most of our practical applications, M30 to M40 concrete should suffice. Only in rare situations you need a mix higher than M50. I'm surprised so many participants are interested in very high strength concrete. Sufficient information is available in Eurocode 2 and American Code 318. IS 456 does not stop you to refer these codes if there is a requirement. Okay. Remember, there are other issues at the site related to such high strength concrete that only a very resourceful contractor can resolve. So it is not a joke to use M40 concrete or M50 concrete or M80 concrete in at site. Okay, so please, come out of the high strength and use normal strength concrete. One of the participants specifically referred to my book in his comments and said that there is no solid example on how to check deflection in a continuous beam. My book gives complete equations and steps for all such cases, including continuous beam. Due to space limitations, it is not possible to add solid examples for every situation. Let us recall that total deflection is a function of three components: delta E, that is elastic component, delta S, which is shrinkage deflection, and delta C, which is deflection due to creep. Okay. Necessary modifications in each of the three components is given in my book. Okay. I have also given two solid examples, one for simply supported beam, other for cantilever beam. Okay. And with these modifications for continuous beam, I see absolutely no problem or hesitation in finding out the deflection in a continuous beam. So my request to that gentleman is to please read chapter 10 again, and I'm sure there will be no difficulty. Now, as far as the column is concerned, between beam and column, column is a very, very important member in a building. If one column fails anywhere in the building, then the entire building will collapse as a chain reaction. Okay. And therefore, we are extremely careful about the safety of a column as compared to beam. If a beam fails, it is going to be always a local failure in that zone only. But if a column fails anywhere, it will trigger a chain reaction and the entire building will come down within seconds. Okay. Now, I don't know how many of you are familiar with this axial force bending moment interaction curve. Okay, it is given in almost all books, but I don't know how many of the participants have paid their attention to this interaction curve. Let me tell you what is the physical significance of this interaction curve. Okay, if you are given a column for a given size, okay, your section is given with B and D, grade of concrete, grade of steel is given, amount of reinforcement is given, okay, then this curve tells you that for under different combinations of P actual force and bending moment M, this column behaves differently. If you see if the actual force is very high, shown by this top, the blue color, I hope you can see the blue color on your screens. So corresponding to this axial force, if you go to the interaction curve, it hits that intersection here. This point, okay, and come down here, you find that the moment of resistance of this column is reduced drastically. Okay, if your axial force is somewhere here, then you get the maximum possible moment of resistance, which is this much. Okay, this much. Okay, column is same, section is same, everything is same, except that the level of axial force is different under different load combinations. Okay, so this gives you the maximum moment resistance corresponding to this level of axial force. This is what we call as balance point. Okay, if your axial force is further reduced, there is a reduction in the moment of resistance of the column. Okay, so what it means is the most desirable range of axial force on a column is this one, which I have shown by this shaded portion, and corresponding to this is the range of moment of resistance of a column. Therefore, what it means is we should try to keep the axial force in a column below 45% of his maximum axial strength. Okay, because during the life of a building, we don't know when there will be some overloading because of any reason, whether it is explosion or earthquake or fire or something else. Okay, so in that case, we have to keep this portion as a margin towards safety. Okay, I hope this physical significance of this MP traction curve is clear. Then another question was about the design of cylinder columns, clause 39.7. Okay, under different load combinations, a given column in a given building at its top and bottom ends will have two situations. Okay, either both movements at top and bottom of a column are in the same sense. That is, both are either clockwise or both are anti-clockwise. Okay, in such a case, the column will deflect in double curvature. One moment is clockwise, either top or bottom, and the other is anti-clockwise. It means the column will deflect in single curvature. Moreover, depending upon the structural system, a story may be restrained to lateral sway or it may be free to sway. Let's study these things in detail. Okay, you can see the left diagram. This is the direction of the bending moment at the top end, which is anti-clockwise, and at the bottom also, which is anti-clockwise. Okay, so it means the column will deflect like this. Okay, column will deflect like this. Okay, and this represents a double curvature. In this second case, this is anti-clockwise, but the bottom is clockwise. And in this case, the column will deflect in single curvature like this. Okay. So what is the idea of knowing the nature of the moments? Because we want to estimate what is the additional moment in the column due to its deflected shape. Okay, and that is the effect of slenderness. Okay, this will introduce additional moments because of lateral deflections in the column. Okay, then second situation is loading. Whether the load is applied at the floor level or load is applied along the height of a column. Okay. In these two loading cases again, the deflected shape will change and therefore the additional moment due to slenderness will change. Third situation is that a, the story is free to sway. Okay, like this. There is no restraint. Second is there is a bracing or there is a shear wall or alternatively there may be a brick infill wall. Okay, if there is this there is a brace shear wall or brick infill wall, that means this frame is restrained to lateral sway. Okay, so these are the situations which are covered in the clause 39.7. Now the question is how to calculate them. Of course, you can do manual calculations. Okay, otherwise, is simpler uh, approach is to develop a simple 2D computer model. Let's say consider a four-story building having five bays, apply different load combinations, and carry out simple static analysis. Okay, and look at the detailed computer output generated by the software for each column. Interestingly, a good software for each column will give you all the parameters given in clause 39.7 in the intermediate results. Okay, and you can spend a couple of minutes or maybe few hours to understand what is happening in the column under different situations. Okay, and what is the additional moment or due to slenderness effect. Okay, also learn how to compute effective length of columns using appendix E of 456 with the help of computer output. Okay, again this question was asked by a lot of participants. Okay, so I suggest please take the help of a good software to clarify your points. Okay, and just carry out simple static analysis and give some arbitrary load combinations to be able to cover the various situations. Then other very commonly asked question was enhanced shear strength near supports. Okay, let's examine this topic in the next slides. We must use finite element analysis to find the answer. Sorry. I know most of you may have heard about finite element analysis, but I don't think they must have got a chance to study it or go into its fundamentals. But anyway, don't worry. My intention is only to expose to the power of FEM to answer this question. Okay, because our routine elastic analysis, which we carry out in our day-to-day affairs, is not going to help us. Okay, now the two important points that you need to keep in mind: the distance of principal load from the face of support and shear span. Okay, let's take a simple supported beam carrying some uniform load and draw a shear force diagram. Okay, this is how the shear force diagram will look like. Okay. Now what the code says, that instead of designing this zone near the supports for the shear force at the support, you can design it for a reduced shear force. Okay, that means you provide the shear reinforcement corresponding to the shear force at section XX, which is at a maximum distance of D, which is the effective depth. Okay, A is the shear span. Okay, so its maximum value is equal to D. Okay, so you design for this smaller shear force instead of the larger shear force, and your building or your beam is safe. How come? And that's what we call as enhanced shear strength of concrete. That means in this zone, the shear strength is much higher than given by our normal codal specifications. Okay, how do you understand this? What do you mean by the term enhanced shear strength, and what causes this shear strength, this enhancement in the shear strength? Okay, so we can get this idea if we carry out finite element plane stress modeling. Okay, I won't go into the detail of either finite element or plane stress modeling because that time doesn't permit it. But all you need to remember is that whatever load you apply on the beam, it all loads will flow towards the support. Okay. Ultimately, equilibrium has to be maintained, and the entire load has to travel to the supports. Okay. So I have this small simple supported beam. I applied a point load here, and here is the support width. Support width is symmetrically loaded uh, beam. Okay, so this shows normal stress sigma 1, that is sigma x contours in the entire beam. Positive value is dark blue and goes down to 0, and negative value is dark maroon. Okay. Now positive means tension, and pink and this means lower portion is compression. So what you see here, when you apply a point load here, this point load has to be balanced by developing very high upward stresses in this zone. Okay? And the normal stress sigma 1. So this is subject to very high compressive stress. This is local zone. Okay. At the bottom fiber, there is a very high tensile stress. Here in this zone, subdural supports, you find this is entire zone is compressive. Here also, entire zone is compressive. Now you know that the shear, we also call it diagonal tension. That means in this direction, along this diagonal, there is diagonal tension. Okay, and because of tension, concrete is going to crack diagonally. You'd get 45-degree cracks, which you call as shear cracks. Okay, now what is this slide shows you that in this zone there are very high compressive stresses. Okay, that means this zone has a natural confinement by compressive stresses here as well as here. Okay, and these compressive stresses we cannot evaluate using the usual elastic methods. This is a large view of the compressive stresses near the edge, support edge. Okay, so in this entire zone, you see there are very high compressive stresses. These are maximum here in this zone. Okay, and because these very high compressive stresses near the edge, the intensity of diagonal tension reduce drastically. Okay. So enhanced shear strength is due to better confinement of concrete by compressive stresses around the support. I hope now this point is clear to you. Okay. Why you are getting enhanced shear strength? Because this entire zone near the support is confined by compressive stresses which are very high and you cannot calculate them by your usual methods. This is normal stress sigma 2, that is the sigma y, vertical axis. Again you see here there are very high sigma 2 stresses which are compressive in nature. Okay. Similarly here, very high compressive stresses at the support. Okay. And so what the code has done, it has taken the advantage of these very high compressive stresses which reduce the effective diagonal tension. Okay. And we have this is a shear stress diagram. You see again, this is shear stress, very high shear stresses are here, very high shear stresses are here. Okay. And this is the result of this confinement. But there is a need to analyze and understand the stress distribution in different zones. Other question was about the deep beams. Okay. Again, we carry out FEM modeling, plane stress to understand the behavior of deep beams. Okay. You will note that there is a change in the depth of neutral axis, therefore lever R. In a deep beam, the formulas for neutral axis which are applicable for shallow beams is not applicable for deep beams. This is the deep beam, again a point load applied here and a support here and here. L by D was 1.5. Okay. So neutral axis, this is the neutral axis here. That's how the neutral axis varies. Okay. You find that neutral axis is not governed by the same criteria as applicable to shallow beams. Okay. This is a shear stress distribution in a deep beam. Okay. So there is a need to analyze and understand the stress distribution in different zones in a deep beam, and this will tell you why there is a need to treat a deep beam differently than a shallow beam. Okay. Then there were a lot of questions about how to design anchor boards in 456. Well, anchor boards design is not covered in 456. Okay, so you may have to refer some European code for latest design practice for anchor boards. Okay. Then another question was regarding the spacing of bars in tension in table 15 of 456 code. Okay. In fact, there is a misprint in 456 in clause 26.3.3. This clause talks about spacing of tension bars in beams. Okay. In fact, if you look at the original specification, which is CB110 or 8110, you find that it clearly says beams and slabs. So when you're providing a spacing of 300 mm or 200 mm between two tension bars, obviously it is applicable to slabs, not beams. Okay, but surprisingly, so many amendments have come for 456, but none of them talks about the spacing of tension bars in slabs. How can you give a spacing of 300 mm or 200 mm in beam? Is ridiculous. Okay. Clear spacing between tension bars is based on percentage plastic redistribution of moments. Okay. If design moment is reduced, the spacing of the bars is also reduced. See, it says plus 10%, plus 15%, plus 30%, or minus 30%. So this plus and minus means what? So you are increasing the moment, plastic moment, or you are reducing the plastic moment because of plastic redistribution. Okay, so accordingly, you are permitted to play with the spacing of bars between tension bars. Okay, remember it's applicable to mostly slabs, not beams. So the plastic moment is increased, the spacing can also be increased. Okay. Now top reinforcement in isolated footings. Lot of questions again. Let me tell you, I have designed so many isolated footings for buildings and other structures. I have never provided top reinforcement in isolated footings. Okay. Some designers are over conservative. Okay. They find a reason to provide top reinforcement. I totally disagree with this over conservative. After all, somebody is going to pay for the extra steel, and then why should he come to you if you are not confident about your calculations, about yourself? Earthquake has become a new tiger in the town. For the last 15, 20 years, there is a lot of noise that earthquake is coming, we are as bad as Japan or China or Italy, which is ridiculous. Okay, there is no concrete evidence that India is a home of severe earthquakes. You can look at the past earthquakes in the last 300 years or 500 years. Okay, only speculation without any data. There is a vested interest at work to convert the whole country into earthquake. Okay. Now, another very interesting question which has come from the participants, especially our young students, by how much percent strength of concrete cube and that of actual RCC member differ? Let me repeat the question. By how much percent strength of concrete cube and that of actual RCC member differ? It's an excellent question. Okay. There are two reduction factors that will apply on the cubic strength of concrete, 1.5 and again 1.5. Okay. That means there's a myth. The myth is that this 1.5 into 1.5 is equal to 2.25 represents factor of safety. That means we are using such a high factor of safety on concrete. That is not true. It's an absolute myth. Let me tell you how. As I mentioned, a lot of participants ask this question. Concrete is a very, very special material, and the strength of concrete is a function of specimen, shape and size, and test arrangement, unlike any other material on the earth. Okay. You take compressive strength of three specimens, 100 mm cube, 150 mm cube, and 200 mm cube. You will find that the pressure, that is load per unit area at failure, is different in all three cases. Why? Okay. At least the load per unit area or the pressure at failure must be same. Material is same. Okay. All I have done is changed the size of specimen 100 mm to 150 mm to 200 mm. You can take any other and you will find no two results will match. The pressure per unit area should match, but it doesn't. Similarly, if you test a cube and cylinder, both 100 mm diameter or 100 mm cube or 150 mm cube or 150 mm diameter cube cylinder, okay, you find again the pressure or the stress per unit area is different. Similarly, the tensile strength of concrete, if you test in bending, and again is split, they are different. Now the question is, what do we do? So much confusion. Okay, no two results are same. And remember, we test a cube in axial compression, but our beam or column is under bending. It's a flexure member. It is not axial compressive member. Okay. So our problem is how to calculate the strength of concrete in flexure, which is realistic. Okay. So what ultimately based on thousands of tests, a lot of brainstorming, they found that fortunately all the properties of concrete are relatable to its compressive tube strength or cylinder strength. Okay, so uh, what they did is this: you plot a stress and curve on either a cylinder or a cube, and you get the top curve. Okay, you get top curve like this. This is the original idealized. This portion is parabolic up to 0.2% and up to 0.3% it is constant. So this portion called as rectangle and this portion we call it parabolic. Okay. So you apply a factor 1.5 to get 0.67 sigma ck. Okay, and this we call as our flexure strength. Okay. So by applying this factor, you are able to convert your axial compressive strength into equivalent flexure strength. So 0.67 goes as goes here, and then you apply a factor of safety to take care of so many other parameters to get our design strength. Design strength. These are our design curve. Okay. Therefore, please don't be in the impression that these two factors are there to take care of some manipulation or other things at site. No, it's purely a technical requirement and there is no scope for any manipulation. Other question is a very interesting question against from where to start the code. I already mentioned in the beginning, a lot of people ask this question. Our lot of young students, third year, fourth year, MTech, code is so thick, so many codes are there. So from where to start? What to look for? Okay. So my answer is start with the concrete laboratory. You are in the student life right now, so don't take your concrete laboratory as a leisure time, but take it seriously. Okay. Uh, then carry out simple designs, simple beam, column, slab, isolated footing manually. Write down or draw the detailed structural drawings for beam, column, slab, one-way slab, two-way slab, and so on. Estimate the material used, steel and concrete, costing, etc. So you must check the corresponding clause in 456 and other codes related to your concrete laboratory, designs, drawing detailing, etc. You must spoil your hands and clothes in the lab. More you spoil your hands are dirty, clothes are dirty, more you will learn. Okay? Laboratory testing of material, testing of sand, coarse aggregate, water, concrete, both green concrete and hard concrete, consistency, etc. Concrete mix design, steel reinforcement, okay, test different bars of different manufacturers, okay, and find out their stress and curve, ultimate strength, maximum elongation, and so on. Sampling, mixing, workability, compaction, curing, durability, and how to carry out optimum mix design. Okay, design of a singly reinforced beam, doubly reinforced beam, one and two-way beam, uniaxial loaded column, simple staircase, isolated footing, cantilever retaining wall, and design them manually. Initially, you can take the help of as many books as you want, as many codes as you want. But with some practice, you should be able to design these elements only with the help of code. No formulas, no referring to the books again. Okay, everything manual. Okay, and you can with a practice of 3 to 6 months, you can do it. Okay, preparation of structural drawings, bar bending schedule, bar bending schedule, bar curtailment is very important and critical. Okay, then quantity estimation again is very important. Again, code is meant for common situations. Okay, there are a lot of questions. The code doesn't cover this, code doesn't cover that. What do I do? And when will code cover this? Remember, we cannot be slave to the code. Even when 50 years ago or 100 years ago there were no codes, buildings were still built. And those buildings are even today iconic buildings. Okay, you take Taj Mahal, you take Red Fort, you take Qutub Minar, okay, take Gateway of India. All these beautiful structures were built while there were no codes. Okay, and they are doing very well today. Everybody is fascinated. So many bridges were built 100 years ago, 200 years ago, and they are still serving their purpose. Okay, so you must know that what do I do because the code doesn't cover my case. You are most welcome to refer any specialized literature, international code, if it is not covered in your code. Alternatively, if nothing works, you're not able to get a, specialized literature or some code, then use your judgment in the best interest of the project, but without cutting corners. That's the condition. Okay. Take your own decision. Most welcome. It's allowed. What to do at the site? Look carefully at architectural drawings and compare with structural drawings. Many times there is a difference in dimensions of architectural drawings and structural drawings. Okay. In case there is a difference, you have to immediately consult the architect and resolve it before it is too late. Many cases have happened where the building was built or with the wrong specifications, and later on they were unnecessarily ugly scenes. Inspect preparation of concrete mix, water cement ratio, placing, transportation, compaction, and curing, etc. Check the bar size, spacing, and curtailment of bars. Check means physically check. Take a caliber, take a scale, and check the spacing. Don't go by the eye judgment or whatever the local supervisor or mason is telling. Because they can be misleading you. Okay, they are totally illiterate and they may be instructed to give you wrong information. You should check the cover to reinforcement, hooks, length of bars, etc. Curtailment locations. Defects in concrete, corrosion in steel, quality of water used at site. Quality of water is a very important parameter. You should be able to drink the water which is being used for mixing concrete, for curing, for everything. Okay. Sampling of test tubes for quality assurance. What people do, they add extra cement in the cubes which are being taken for quality assurance. Make sure no extra cement is added at the time of taking out those cubes for quality assurance. Acceptance criteria for concrete. Okay. You must understand that I'll give a lot of examples in my book on limits of design about the acceptance criteria. There are some questions about acceptance criteria also. Okay, so it is given in my book, and I think that should be sufficient. Another question is, how do I become a good designer? Okay, you need to be a very good analyst in order to become a very good designer, because you can design a good building provided your member forces, that is axial force, bending moment, shear force, hogging bending moment, sliding bending moment, and deflections are correctly estimated. Okay, what it means is you have to have a total command on the analysis of statically determinate structures and indeterminate determinate structures as well as indeterminate structures. You must learn Excel worksheet and also working with macros. Okay. Nowadays, most of the designs of very large structures is done by homemade Excel sheets. Okay, including drawings. Okay, so Excel is a very powerful tool, and each and every person, especially our young blood, must learn and do mastery on macros. This is the cover of my forthcoming book, third edition, 23. It will be released in the first week of next month. It will be available on Amazon, and this has been totally rewritten based on whatever feedback I received in the last uh, more than 3 decades. Okay. Then there were questions how to carry out P delta effect on uh, columns and building frames. Okay, I have added a new section in my advanced structural analysis book, chapter 15, on geometrically nonlinear problems. Okay, so I have added example of period analysis. Okay, so this again is fourth edition, 23 is releasing the first week of next month. Okay, advanced structural analysis it will be available on Amazon. In fact, both the elementary as well as advanced they will be shortly available on Amazon, and interested persons may wish to go for them. As far as my reinforced concrete book is concerned, the latest edition is still the seventh edition, 2012. I'm waiting for the next revision of the code, and then I will think how to revise that this edition. Okay. In the meantime, I must thank all the users because the first edition of this book came out in 1983, 40 years ago. And in these 40 years, 7 editions have been published with number of reprints. Okay, and they made this book a great success all over the country. Okay, so I'm really thankful to all my readers who made it a great success story. Thank you so much. Now, time for question answers. I'll try to answer as many questions as possible. Thank you.
Yeah, yes, yes. Yeah, thanks a lot, sir. It's a very, very interesting and excellent presentation and covering, I think, majority of the points which were repeating. Yes.
That's what I was trying to.
Yeah. Mm, okay, so this, so okay, so you can stop the sharing now. Okay, Dr. Ajay Shah is telling sir, thanks, Dr. Jain sir, for a nice lecture.
Thank you. Thank you. Thank you, Dr. Shah.
Yeah. Okay, Satish Kumar is asking how to select the materials based on their design life period.
See, I think the concrete code or materials tells you what should be the specifications of sand, coarse aggregate, cement, etc. If you
Mm.
follow those specifications, you're good for maybe 75 years to 100 years.
So right now there is no mention of design life period in current version of the code.
For materials, it's not possible.
Right,
There,
right.
whatever possible you can do is already
Hmm.
mentioned there.
Hmm. Hmm. Okay, Quasi Inam is telling, sir, it was a treat watching you after a long time. I was afraid of approaching you in Roorkee.
He must have some of my students or what?
Yeah, I think he can reply in the next chat, like how he was connected with
I hope not true.
you. Yeah, yeah. Okay, I think Rajesh is asking if possible, kindly share presentation if possible.
Yeah, Bhavin Shah will share the whole
Yeah,
presentation.
sure. Sure, sir, it can be done. Yeah. Pujan is asking, sir, if you look at the site, the steel reinforcement is already affected by corrosion. Then what needs to be done then?
It has to be cleaned.
Hmm.
There are techniques how to clean it.
Hmm.
It has to be cleaned. You cannot
Hmm.
use corrosion. I
Hmm.
tell you, lot of brand new buildings, two years old,
Hmm.
2 years old, 5 years old, they are in a very bad shape because of corrosion. Partly because the steel was already corroded, and secondly, the water that was used
Hmm.
contained chloride and
Hmm.
sulfate.
Hmm. Hmm.
So don't take chances. It's a nightmare. It's a nightmare. You can't fix it.
Hmm.
There are some agencies who will say now we'll fix this corrosion. They will rip you off, and output is zero.
So,
So please be careful. Thank you.
yes. Okay, Quasi Inam is telling, sir, he was a PhD student under Dr. Akhil Upadhyay.
That's why he went to Akhil, not me. Anyway, good luck.
Okay. Vaibhav is telling, sir, our code do not explain to start with minimum pile cap thickness.
Why it has to be mentioned? You
Hmm.
can design the path signals yourself. It's
Hmm.
not difficult.
Hmm.
You can check it for one-way
Hmm.
shear and two-way
Hmm.
shear, and that
Hmm.
will govern the design.
Right.
Why do you want everything to be told by you by the code? If suppose code says 2 years, 2 meters, and the requirement is only 1 meter, why go for 2 meters? So don't, give the handle to the code.
Hmm.
Keep it in
Hmm.
your hands.
Yes. Prasad is asking, sir, can you please a little bit explain to the concept of cracking pattern of beam?
It's a very, very complex subject. Because there are cracks due to so many reasons. Almost 25 years ago, Gujarat Ambuja, I Dorji, I think his name was Dorji,
Mhm.
for Ambuja Cement.
Uh, yes,
He
sir.
published a
Mm.
small booklet on this concept of cracking patterns. Because Gujarat Ambuja published a lot of publications,
Mhm.
10 pages, 20 pages publications. I have some
Mhm.
of them. Okay, I will share with Mr. Bhavin Shah,
Sure, sir.
and we can upload it.
Mhm.
And they give beautiful explanation about the various aspects of plain concrete and so many things, and all in small booklets, 10 pages to 20 pages.
Mhm.
Okay. So unfortunately, because of this takeover by different companies, those literature have lost. I still have many of them. I was
Mhm.
I was collecting them seriously. They published about 130 publications. I don't have all of them, but I have
Mhm.
most of them. So please refer them, and they should be able to answer your question.
Yes, sir. Why cube strength is false?
Yeah, I told you.
Mhm.
You are testing a cube in actual compression, whereas your actual behavior of a beam, column or slab is flexure. The mode is different.
Mhm.
But our problem is we can't test a plain
Hmm.
concrete beam, a plain
Hmm.
concrete column in bending. The strength will be zero because concrete is so brittle. Therefore, we have to test a concrete cube in axial compression and convert it into flexure. And whatever recipe our forefathers have discovered is working fine based on
Yes.
experimental results.
Hmm.
Okay,
Okay, Dhawal is telling, thank you, sir.
welcome, thank you.
Pujan is telling, sir, epoxy coated steel bars are available in the market. So can we use that?
Sure, they are allowed. They tell you how to calculate development length, etc., or bond
Hmm.
strength, but you can
Hmm.
use them. But my question is why? Why you want to increase the cost? Okay, take normal precautions. Okay, about material and cover. That is sufficient. Even
I
in
see.
coastal areas, even in coastal areas. See, marketing people will sell you anything,
Hmm.
but you have to use your guts
Yes.
and your
Yes.
yourself. Okay.
So can you give some basic idea between corrosion and rusting of reinforcement?
Same.
I think same, right?
Yeah, same.
Okay, Shashank is telling, sir, I wonder if the software design based on the maximum shear force at the ends or optimized by the design for the section at some distance from the ends.
Good software always designed based on distance d away.
Hmm.
Very clearly it's mentioned. Yeah. They all design d away. Otherwise, who will buy the software?
Yes.
Who will buy the software?
Hmm.
Check it again.
Will old and new concrete bind in slabs and beams with dowels which are projected if
Yes,
concrete
yes, yes.
is
It
done in
is
slab?
time-tested procedure. Time-tested. You have to take some more precautions, but
Hmm.
it is perfectly okay.
Yes.
I mean, there are buildings which have been
Hmm.
built or continued after 10 years,
Yes.
okay, and they're working fine.
Hmm. Yes, sir. Nikunj is telling, sir, corner column footing designs are not available for study. Can you please suggest any books or literatures with example?
Well, nowadays you can easily use softwares. People, you can use even SAP 2000 or that other one, what was safe.
Hmm. Hmm.
Okay, that is the best
Yes.
because no matter which as a for example you use, it will be very very approximate, very
Hmm.
conservative.
Hmm.
Okay, we all have been designing corner column footings, but on the conservative side. Okay, so but if you want a rational design, I suggest go for software which are designed only footings like safe. Even STAR has a module for foundation design. You can use that. Yeah.
How much maximum steel reinforcement in column can be used? Let's say code says 6% is permissible, but practically we can't go more than 4%.
No, no, no. You can go. That is also more than 4%. Only thing is steel becomes very congested.
Yes.
It's difficult to pour concrete, but it's
Hmm.
not impossible. It's not
Hmm.
impossible. What the
Hmm.
code is saying, instead of going for specialized techniques for using, the flow of concrete, or
Hmm.
if you keep yourself 4% and increase
Hmm.
the size of concrete column, that is better.
Hmm. Hmm.
So that is the intention behind it.
I see.
Increase the column size to keep the steel at 4%. Otherwise,
Hmm.
it will go up to 6% or even 8%
Hmm.
in columns. Okay. Only thing is concrete will become little difficult.
Hmm.
That is the reason behind it.
Yes, sir. Okay. Quasi Inam is asking, sir, please make video playlist on advanced concrete design based on your book content.
Sure. But how many people are going to pay for it? They're already using pirated SAP, pirating ETABS, pirated, that STAD and whatnot. The whole country, the whole design industry is based on pirated software, whether it's whether it is AutoCAD,
Mm,
even Windows.
mm,
So that is the problem.
yes, sir. Clause B 5.5.1 and B 5.5.3 are contradictory. Any clear-cut value for shear at d by 3, say?
There can be some small contradictions. It's possible. I
Mm,
don't know what is clause, okay,
mm,
but it's
mm,
possible that there may be some minor.
yeah. Why we consider a constant stress after 0.002 strain?
It's based on experimental evidence.
Mm,
Number of tests have been carried out at different researchers, and
mm,
everybody came to the same conclusion. They all
mm.
that's why I said start with the lab. Okay, if you
Yes, sir. Couple of books I have read when I was working under Latch in SCC Concrete and R&D. Thing. Sir, kindly explain punching shear reinforcement arrangements.
uh, it is difficult to do it at this
Mhm.
in this
Yeah,
presentation.
yes, can be
So
taken up, sir. Yeah.
I need to draw some sketches.
Mm,
Okay, to explain this phenomena, we can do it separately.
mm. Okay, so Prasad is telling, sir, thank you so
Yeah,
much.
thank you so much. Thank you. Most welcome.
Yeah. Explanation in IS 456 table number 15.
I
Yes, not
already
specific.
explained.
Yeah, already
This
explained, sir.
table I've already explained.
Mm. Concrete which is already crossed 50 years. What we have to check and confirm for health assessment. If strength is showing good results, what should be other checks?
Well, if the concrete has crossed 30 years or 40 years or 50 years, even 80 years, you can carry out a physical inspection. And if you don't see any cracks, okay, there is no leakage of water or seepage, okay, then you don't have to do anything. Just plaster it wherever it is required and
Mhm,
make sure the water doesn't get accumulated anywhere.
mhm, mhm,
I have done a lot of physical inspections in coastal areas, including I've done a lot of inspection for IFCO
mhm.
at their different ports, and they're all in excellent conditions even after 30 to 50 years. Okay, so nothing is to be done. Nothing is to be done.
So can you enlighten on LC3 cement?
I don't know what this cement is.
Yeah. Okay. Cylindrical paste specimen. Some point. I think this is what we've discussed. Okay.
We already discussed this.
Yeah. Nico just telling, sir, can we use column thickness less than 200 for G+1 structure if they pass in the design?
See, the thing is, you have to use your judgment and make sure that it doesn't slender. In a G
Mm,
plus 1 story, 20, 200 mm, 150 mm, even 100 mm have been provided. Okay, and they are doing well.
mm,
That's why I'm saying don't hand over the control to the code,
mm,
because if you send this design for proof checking, it will fail.
mm. Yes.
Okay, so if you think that 200 you require a 175 mm or 150 mm in the residential building, go for it. See, our specifications are based on 50 years ago specifications. That knowledge which was available in 1971, maybe before that. Okay,
Mm,
in those
mm,
days, we using M15 mix with the mild steel and 33 grade cement. Now we are using 50 grade cement, 44, uh,
mm.
55 or something.
Yes, sir.
Okay, and we are also using high strength steel. So why
Mm,
not take advantage of that in reducing the member sizes? We should.
yes, sir.
We should.
So how to find compressive stress in bar with respect to PM interaction, as it may also govern depth of footing as per IS 456 and SP 34.
I don't understand what you mean by it.
The question is
Uh,
not easy. Herein, this is asking, as self-compacting concrete is now available, can we use more than 6% steel in the columns?
that's what I'm saying. That 6% or more than 6%. See, if you can satisfy the codal specifications or minimum spacing between the bars, cover, etc., then I don't care how much steel you want to provide. Okay, but you must be able to satisfy the spacing criteria. And remember, there are issues with self-compacting concrete. It's not a cakewalk.
So, okay, so okay, now the question is coming on age formula. So let's keep sir at this point at this moment.
No, we are
Yeah,
not talking about.
we're
We are not
not
talking about
talking.
earthquake at all. No,
Okay.
no earthquake.
Okay, sir. So we have reached our time, 12:30. And Nikunj is telling, sir, thank you so much for your guidance.
Thank you, most welcome.
Uh, yeah, and we can see that still, sir, few the comments are popping up. So we'll work out certain more mechanism to address this, because there are still few many interesting points we have.
Yeah,
So,
I'm
so
sure. I'm sure there are. Yes,
yes, sir. Yes, sir.
and I'm
So
very
we'll work out.
thankful to all the
Yeah,
participants.
yeah. Yes, sir. Yes, sir. Yes, sir. So we are very much thankful for all the participants to share this question. So then that's why this session was organized. Okay. Yes, sir.
Thank you.
Yes, sir. Okay, Sashank is telling very good presentation. Thanks a lot, Sashank. Okay. Okay, so with this, we are closing this presentation, and we will be looking forward for your feedback regarding this session in the comment box. Okay, and this video will be published on YouTube. You'll be able to see this discussion again if you missed out certain part of it, and please keep following us, because we are planning so many other interesting initiatives, and we are always looking forward for your input on this. Okay, so we'll meet very soon once again with very interesting live discussion. So till then, goodbye from our side. So we are just closing this session now. Yeah.